Alright guys, so now we know now about Sussex trees. Let's see a way that, one of the ways, and I'll get into the other ones later in a different chapter when we talk about sequence alignment. But just to kind of give you a sense of how the Sussex or the suffix trees would relate potentially to how some piece of software might align two sequences to see what the consensus sequence was. So if we take these two particular things here, the easiest thing to do is break them up into smaller pieces. So basically just start like right here and just grab kind of these four and then just go kind of letter by letter. So if we do T, T, G, G, and then we go T, G, G, C, and then we go G, G, C, C, and then we go G, C, C, A, and then we go, as you can see kind of what I'm doing here, C, C, A, and then finally C, A, T. So we're just kind of breaking up into smaller sections, and then we're going to do the same on the other side and then see if we can find any consensus between them, which might be where the actual alignment occurs. So let's just kind of do, in essence, the same thing over here. So let's go, we'll just start again with these. You can do 3, but I usually do 4, whatever. So C, C, A, C, A, T, A, T, A, T, and then finally T, A, T, G. And you can kind of see here that obviously this one's a little shorter because this one happens to be just 9 nucleotides long and this one's 8. So basically now we see those, and that now we kind of go, do we find any of these over here? And that's kind of what we're looking for. So we do. We see that right here there's C, C, A, and there's also C, C, A here. So those two kind of connect to each other, and then look, we have another one, CAAT and CAAT, and so there clearly is the area of overlap. So if we were to figure out like what would the actual true sequence be, the way that we would kind of do that would be just, it'd be T, T, G, G, C, C, A, and now if you kind of look right here, you can see that we have that CCAA on both sides, all right, and the CCAAT on both sides, right? So there's our T, and then all we do is just write the last 3 after that, which would be an A and a T and a G, and that is the, whoop, you can't see that, sorry. That is the actual consensus sequence in a de Bruijn graph, taking 2 individual sequences to kind of find the areas of which they overlap.